Hi, we're going to do another problem today on specific heat. And so we talked about our equation for specific heat, which related temperature, mass, and the energy that it takes to change the temperature. And so what we have here is we've got a problem that says, what is the temperature change if 345 joules of energy is added to 45 milliliters of water? Now remember, one of the things you always want to do when you see an equation or a problem like this is try to figure out if there's an equation that you know that relates to it. And so the equation that we know here relates heat equals mass times specific heat times a change in temperature. Now in my class I ask you to memorize that equation, so it's one that you know and you can work with just by seeing it. How did we know? We had joules, we had an amount of something, and we talked about energy, right? And we asked for a temperature change. If you see those things in a problem, that's the equation you're going to be looking at. So here, what do we have? Well, whenever we have problems like this, just like we did in other problems, we want to look to see what do we have and what don't we have. So here, first thing is, do we have anything about heat? Well, the answer there is yes, we do have something about heat. We were told that we have 345 joules of energy that was put in. Okay, and then we want to know about mass. Do we have anything about mass? Well, if you look at the problem, there's nothing directly about mass there. So we'll come back to mass in just a second. Specific heat. That's not given in the problem either. So let's come back to that. And a temperature change. Well, the problem actually asks for a temperature change. So let's go ahead and put that temperature change in just like that. And so that's what we're looking for. We're looking for that temperature change. Still need to figure out mass and specific heat. If I give you a problem like this, you know that there's some way of doing it, so you're going to figure out how to do it. Well, let's think about mass. Do we have anything that might tell us about mass? Well, what does mass tell you? It's kind of how much it weighs, right? Not technically, but how much it weighs, how much of it there is. Well, milliliters. That also talks about how much there is. Is there a way we know to take milliliters and convert them into grams? Well, what would that conversion factor look like? That conversion factor would have grams on the top, milliliters on the bottom. That should look familiar. Grams over milliliters. That's a density. And in my class, I asked you to memorize that the density of water is 1.00 grams per milliliter. We have water up here. Anytime you see this word water, that is a key word for you, and you should be able to think about things like its density. So if you do that out, you get 45.0 grams of water. So we can go ahead and substitute that in our equation up here. I'm going to delete the m, and I'm going to put in 45.0 grams of water. Okay, so we now have their energy, we've got our mass, we need our specific heat, and there's got to be some way of finding that specific heat. And it wasn't given in the problem statement. So what do we do? Well, it turns out the specific heat of water is another number that I want you to memorize. And that is 4.184 joules per gram degrees Celsius. Now when you memorize that, make sure you memorize the number and the units, not just the number. We also remember from our conversions that 4.184 joules is 1 calorie. So this is 1.00 calories per gram degree Celsius. So those two numbers, the specific heat of water, those you should just know. So when we see up here that we are talking about water in our problem, we can delete that specific heat right there, and we can put in what we know. Which unit do we want to use? Do we want to use calories or joules? We look over here, and on the left, we've got joules. And so what we want to do is use joules. 4.184 joules per gram degree Celsius. I apologize, it's a little squished there. And now we have everything we need. We're just solving for delta t. Now, delta t, even though it's two letters, is just a variable. It's just like solving for a. So we're going to go ahead and do that. We're going to take delta t. We're going to divide both sides by the 45 and divide both sides by the 4.184. So you get 345 joules divided by 45.0 grams times 4.184 joules per gram degree Celsius. There's a lot of units there, but keep your units in as you're going. Remember, if you don't know the units at the end, you're just making them up. Okay, so we've got that there. You plug that into your calculator, and your calculator gives you a number. What about our sig figs? Well, we've got how many significant figures? 3 sig figs in this number. We've got 3 sig figs in this number. This one, if you remember, is exact, and so we don't have to worry about its sig figs. So we should have 3 sig figs in our answer. You plug that into your calculator, you should get 1.83 degrees Celsius. How did I know the units? Well, I canceled out the things that can cancel. This joules cancels with this joules because one was on top, one was on bottom. This grams cancels with that grams, one was on top, one was on bottom, and the only unit left is the degrees Celsius. And so we get that we can heat up the water by 1.83 degrees Celsius. Okay, hope that problem was helpful.